Jupiter's radiation belts are the most lethal environment in our solar system outside the Sun itself. We're talking about a death zone so intense that it makes nuclear reactors look tame. This is the story of the invisible killer surrounding the largest planet in our cosmic neighborhood. Picture this. Jupiter's magnetosphere is 20 million kilometers across. That's 150 times wider than Jupiter itself and almost 15 times the diameter of the Sun. It's the largest structure made by any planet in our solar system. But size isn't what makes it deadly. Inside this magnetic bubble, Jupiter traps charged particles and accelerates them to absolutely insane speeds, creating radiation belts that would kill an unprotected human in hours. How deadly are we talking? Jupiter produces radiation equivalent to 100 million X-rays. If you stood on Europa, one of Jupiter's moons, you'd receive a lethal dose of radiation within hours. The numbers are staggering. Over the course of a typical mission, a spacecraft near Jupiter gets bombarded with over 20 million rads of radiation. That's more than 100 million dental X-rays worth of punishment. For comparison, 500 rads is enough to kill a human. But here's what makes Jupiter's radiation belts truly terrifying. They're not just intense, they're accelerated. Jupiter's magnetic field is 20,000 times stronger than Earth's. As the planet spins every 10 hours, this massive magnetic field whips around like a cosmic particle accelerator, grabbing electrons and protons and flinging them to near light speed. These particles become subatomic bullets that can pass straight through solid metal and fry electronics instantly. The history of exploring Jupiter reads like a casualty list. When Voyager 1 flew past in 1979, it received a radiation dose 1,000 times lethal for humans. The damage was so severe that it lost most of its high-resolution images of Io and Ganymede. Pioneer 11 barely survived its flyby, saved only because Jupiter's magnetosphere happened to wobble upward at that exact moment, moving slightly away from the spacecraft. Without that cosmic luck, we would have lost it entirely. The Galileo spacecraft, which orbited Jupiter in the 1990s, had to be completely redesigned to handle the radiation. Even with radiation-hardened electronics, its instruments suffered serious degradation. Engineers learned the hard way that Jupiter doesn't play by Earth's rules. So how do we survive this hellscape? Enter Juno, NASA's current Jupiter orbiter, and the most radiation-resistant spacecraft ever built. At its heart is a titanium vault 1 centimeter thick on all sides, weighing 200 kilograms. This armor reduces radiation exposure by a factor of 800. Inside Juno's brain is a RAD-750 processor designed to withstand 1 million rads on its own. Even the wiring has braided copper and stainless steel sheaths for protection. But the vault alone isn't enough. Juno's orbit is specifically designed to minimize time in the worst radiation zones. It makes highly elliptical loops that dip close to Jupiter's poles, then swing far out, spending as little time as possible in the deadly equatorial radiation belts. The spacecraft's solar panels use glass twice as thick as normal and are oversized because engineers knew the radiation would degrade them over time. Europa Clipper, launching soon to study Jupiter's ocean moon, takes this even further. It has twin radiation vaults with carbon fiber walls reinforced with lead. The mission will make 49 flybys of Europa, but each pass through the radiation zone lasts less than a day before the spacecraft zips back out to safety. Why does Jupiter have such killer radiation? It comes down to two factors: that monster magnetic field and a volcanic moon named Io. Io spews out tons of sulfur and oxygen ions that get trapped in Jupiter's magnetosphere. The magnetic field then accelerates these particles to extreme energies, creating a radiation environment more intense than anywhere else in the solar system except the Sun's surface. This isn't just a spacecraft problem. Any future human mission to Jupiter's moons would face an existential threat. Standing on Europa's surface, an astronaut would be dead within hours from radiation alone, even in a spacesuit. The radiation penetrates everything. Jupiter's radiation belts remind us that space isn't just empty and cold, it's actively hostile. The same magnetic fields that create Jupiter's beautiful auroras also generate an invisible storm of death that has destroyed instruments, degraded spacecraft, and forced engineers to build armor-plated robots just to get close. This is Jupiter's deadly secret. The king of planets is surrounded by the most dangerous radiation environment humanity has ever tried to explore. And we are still learning just how lethal it really is.